Okay, so implicit differentiation, AP Calculus AB. In this specific question, we're actually asked to apply our knowledge of implicit differentiation to find the equation of the line tangent to the graph of f of x is equal to x squared times the quantity x squared plus y squared set equal to y squared. And they gave us the point, and the point they gave us was square root of 2 over 2, comma square root of 2 over 2. So I verified that this point does exist on this graph, so that's true. So what I'm going to start doing now is actually I'm going to do a algebraic simplification first, if you don't mind. And all I'm going to do is I'm going to distribute here. I'm going to distribute this x squared to here and here to make sure that I am doing this in the simplest way possible. And that gives me that, wow, it gives me these little dotted lines. That gives me that f of x is actually equal to x to the fourth plus x squared, y squared is equal to y squared. And I'm going to go ahead and I'm going to take the derivative of this whole thing. And that's my big plan here. So I'm going to take this piece out. I'm going to take the derivative of this whole thing. And say dy dx of this whole thing. Part of this is just convention. What does it look like when you do this, or how will your professor do his or her proof? It would look something like this, and he or she is going to say that they're going to take. They're not going to take ddx. They're going to take ddx. So they're going to say they're going to take ddx of x to the fourth plus they're going to take ddx of x squared y squared, and on the other side they're going to take ddx of y squared. This is just them signaling their intention to you of what they're going to do. I'm going to go ahead and do some of this because some of this is pretty easy to do. And we know from basic calculus that the first derivative of x to the fourth is 4x cubed. Hopefully we know something about implicit differentiation, and we should know that the first derivative of this is the derivative of the outside, which is 2y, times the derivative of the inside, and the derivative of the inside is dy dx, isn't it? So I'm going to leave it like that. Now what we have to do, and it's just a little bit more complicated, is take this derivative of this piece inside here. I meant to do this, but whatever. Right, so I'm going to take the derivative of this piece on the inside here. So let me see, I'm going to just switch pages for a second and do that over here. So we want to take the derivative, I'll use this for a second, ddx of x squared, y squared. So the way I'm going to do that, I think, is I'm going to set this up as a product rule. So I'm going to set up my little thing, say f of x is equal to x squared. So I'm looking at this is this times this is what I have. The first derivative of that is f prime at x is equal to 2x, isn't it? The g of x portion is going to be equal to y squared, and the first derivative of y squared, as we just saw on the last page, is 2y dy dx. I'm going to put this together using the product rule now, which gives us x squared, doesn't it? Times 2y dy dx, plus, this is just me filling in the blanks on the product rule, y squared, right, times 2x. So then I'm going to take this piece right here, and I'm going to substitute it back in on the side that we were just working on. I'm going to go back to that page right here. I'm going to put all my work that we just did right in here. And what that gave us was, if you remember, was x squared 2y dy dx plus y squared times 2x. Right, now we have all of our pieces together. Move this piece over here. Right, so that's where we are right now. Now what we're looking at is where I want to move everything that doesn't have dy dx to one side. So if we do that, it's going to end up looking like this. And you can follow along if you will, please. It will give us this. It will give us, that's what I'm going to do. I'm going to move over this 4x here. So I get negative 4x cubed. I'm going to move over this 2xy squared. I'm going to, if you don't mind, I'm going to write it that way. I'm going to move that over as a negative, so 2xy squared, if you don't mind. It leaves me on this side with all the stuff that has dy dx, and that's this piece, isn't it? Oh, and I want to move this piece over this way. Is that all right? So that would give us this x squared, so that gives us x squared 2y dy dx minus, because I moved this over, right? So I subtracted this from both sides, 2y dy dx. You're going to be so excited to find out that we're almost done with this differentiation part. It's not zero, it's just a pain in the neck. Now what I'm looking and noticing, and hopefully you're noticing it too, is that we have, both of these have terms of dy dx. So that's what we're going to do. We're going to factor that out. So I'm going to factor out dy dx here. I'm going to get a factor of dy dx times x squared 2y minus 2y, right, is equal to, here I'm going to just go ahead and just do a little bit of factoring. I'm going to factor out the 2x from here, I think I can take out. So negative 2x times x squared minus, what is it, minus y squared? Sure it is. Oh, I factored out a negative, so I have to put a plus in here, plus y squared. Somebody out there was waiting for me to screw that up. Good job, you guys. All right, so let's just keep moving. We're doing fine. This is not the easiest thing in the world, but we're going to be able to do this. If you look at it now, all we're going to do is divide both sides by this piece right here. So this is what I'm doing, and the next step will be what it's going to look like. I'm going to divide the whole thing by this. I'm going to divide both sides by this, which on the left-hand side would just leave us with dy dx, won't it? So now we're at dy dx is equal to negative 2x times x squared plus y squared all over, exactly. Oh, you know what? I can factor out a 2. I can factor out 2y here, so I'm going to factor out 2y x squared minus 1. Does that make sense? Just doing this algebra because I know on the AP exam they're going to force you to do this algebra, so we might as well get sharp at it now. The 2's, factors of 2, they cancel each other out. What usually will happen is that this negative will be slammed back into one of these things at the top or the bottom. So this negative sign right here would usually be multiplied through here. I'm not going to bother with it, but I just want you to see that. So this is our dy dx. Just when we thought it was safe to go outside, just when we thought we were finished, we're not quite finished, are we? Because what we're asked to do is find the equation of a line tangent. So now we have to do this. We have to remember that y minus y sub 1 is equal to m times x minus x sub 1. And if you're mad right now, you're like, who cares about this? You care about this desperately, because without this, you're not going to be able to do what's asked of you on the AP Calculus exam. So you have to become really familiar and comfortable with this point slope form. Okay, so what is the slope? Well, how would you figure out the slope is that, remember, we had x and y points. We had x and y points of this, so we're going to say dy dx of the point that we're looking at. And all I did here was plug in these values and said square root of 2 over 2 times 2 times square root of 2, square root 2 times 1/2. I'm doing some of this math out because I don't want to do all of it, to be honest with you. Plus 1/2. I already simplified tons of this, so if you're getting a weird answer, you're like, what's going on? Go back and do this arithmetic. I just didn't have time to do it all. 1 minus 1/2, because remember this is squared. So that would give us 1/2, wouldn't it? And that would all be equal to 3 over 2 over 1 over 2, otherwise known as 3. Wouldn't that be great if all we were asked to do is find the slope, because there's the slope, but we're not asked to find the slope, we're asked to find the equation of the line tangent. Therefore, we take this point, right, and we put it in, we say y, and I'm using this, I'm plugging into this right now, minus square root 2 over 2 is equal to 3 times, the slope was 3, times x minus square root 2 over 2, right? Because that's the x value. I'm sure you'd love to stop right now, but we might as well finish. So we'll get y is equal to 3x minus 3 square roots of 2 over 2 plus square root 2 over 2. And if you're wondering where this came from, I just moved it over. I just moved it over as part of what I was doing. And this will give us y is equal to 3x minus 2 square roots of 2. Sorry, yeah, 2 square roots of 2 over 2, which gives us, finally, our final solution is y is equal to 3x minus square root 2. We're going to do so much. It's going to get so good at this. You're going to speak this like it's your first language. It's going to be brilliant. You're going to be really, really good at this. This problem is clever enough that this actually could show up on free response. So that would be a great way to knock out some points on the free response section of this exam. If you're sitting here and you're like, yeah, I'm in college calculus, I'm not in AP calculus, this is going to pay off for you big time, because you're going to see this over and over again, and you're going to see this in Calc 2 and Calc 3. So we might as well be really, really good at what we do. So I really appreciate you guys watching the video. If you haven't already subscribed, please subscribe. Your support is really, really appreciated, and your comments are always welcome.